All right. Welcome back, or welcome. In this lesson, I'm going to talk about the cybersecurity fundamentals, the architecture, right? And in this one, I'll talk about the fundamentals, what it is, the different types. Um, we'll talk about deployment and the different types of deployment architectures within it. And if I have enough time, I'll talk about IP tables and um, on the Linux side with the NFT tables. NF tables, right? And packet flow. Again, this is all in case, but my goal here is to talk about the fundamentals and, you know, understand what you're going to be learning here and how a firewall works. Firewall works well with NAT, network address translation, and network NAC. We call it network access control. And then if we have enough time, we'll get to the architecture. We'll work our way up just to kind of. And we'll show leadership. We'll talk about trade-offs of a firewall, different types of firewalls, how it works in different scenarios. And we also talk about firewalls with the different architectures. So again, get started. Well, just remember something: architecture, and I guess internal, external. Again, there's the types of firewalls, right? And the different firewalls stem from. Okay, so it's not a device. Okay, when we're talking about, it's about framing it. If I were to frame this in strategical trade strategy or technical strategy or a trade-off, or just in terms of design thinking and how a CEO would describe it, in terms of risk, in terms of business value, in terms of competitive positioning, in terms of leadership, right? We start off with the actual frameworks and the fundamentals aspect of it, because you have to understand that, before we even get into what the architectures are, you need to know what the fundamentals are. Never like, if you're coming from a tech background and you know a little bit, it's always good to refresh and take these courses that are out there to kind of learn it and take those notes and learn them for that, because firewalls are the gatekeepers, right? For especially for network and network security. These firewalls examine traffic flowing between the networks, and obviously they make decisions to allow or just block based off a defined rule. Now, for security professionals in cybersecurity, understanding firewalls means understanding how to configure defense, you know, how do attackers attempt to bypass them, and how how to analyze these fire logs during investigations, right? So, we try to I'm trying to cover the concepts of like packet filtering to a next generation application, right? And you'll learn how to write firewall rules and whatnot in the fundamentals and the professional course, right? And then the architecture, you're learning about the trade-offs and the design, right? But for now, let's talk about how you'll learn about the basics, right? And you'll also learn how to write firewall rules. You'll understand what NAT is, network address translation. You'll understand the implement network access control. And with these skills obviously are essential for security engineers, SOC testers, and pen testers, right? But again, fundamentals. You're learning the fundamentals, and you'll also get to the architecture, right? If this is something that you're interested in, again, please follow along, right? Sec. Just gonna make this a little bit bigger. I want you guys to see it. Right? Security engineers, SOC analysts, pen testers, right? They're all alike. And by the end of this lesson, you will be able to explain the different types of firewalls and their capabilities. You'll be able to write and analyze firewall rules, right, on Linux and IP tables or NF tables and in Windows, right? And this is the part of the fundamentals, right? And then we'll start talking about the architecture and how the architecture um, we can frame the architecture and describe it as not just about firewalls, it's about risk management, right? Now, how it's a central point in risk management strategy. But let's get to the point where this kind of makes sense in terms of how we would go around that, right? So, I want to welcome everybody back here. I'm Sal Cosentino. I'm a chief executive officer of INProduction by INC2. I'm also a cloud architect and trainer. Today, we're not just talking about firewalls. We're talking about how firewalls decisions reflect leadership, architecture maturity, and business strategy, right? So we're going to learn a little bit about fundamentals. We're going to learn a little bit about trade-offs. We're going to learn a little bit about leadership. We're going to learn about how packet filtering to next-gen firewalls NGFWs and how the perimeter models to zero trust design. I'll break down not only how these technologies work, but the real trade offs behind them. If you're a cloud engineer, an architect, a security professional, a security analyst, a security engineer, a SOC analyst, a pen tester, or even a technology leader, this video will help you think beyond configuration and start thinking in terms of risk, performance, cost, long-term strategy. So let's dive into firewall fundamentals, the technical depth, and the leadership mindset behind it. Because at the end of the day, the real leadership, and then I'll give you guys some concepts and conceptual context between the technical concepts and the leadership concept, right? So if I were to, as a cloud architect, I evaluate firewalls based on risk reduction, performance, and operational complexity, right? So stateless firewalls for me, and I'll explain what those are too if you guys are new. They offer speed but limited context, right? So stateful inspection provides that balanced protection. The next generation firewalls, obviously, they integrate identity and sorry guys, give me 1 second. right? I choose firewalls based on, again, my apologies. I choose firewalls based on how much they reduce risk, right? How fast they run and how hard they manage. A simple firewall is fast, but doesn't understand much about the traffic, right? So when we talk about stateful firewalls, and we'll dive deep into a little bit of that in the fundamental side, moving towards the architecture, but because it keeps track of the connection, it gives more protection, right? So that next generation firewall is the most advanced. So it can see apps, applications, it can see users and threats, but it costs more and needs more management, right? As a business leader, I see firewalls as tools. They protect the company's data, they protect the company's money and the reputation of the company. So the best firewall choice depends on how much risk the company's willing to take, what rules it follows, and how fast it wants to grow, right? So, you know, I'm going to, like I said, I'm going to talk about the not the technical accuracy part of it, but we can improve on mentioning security leaders, or we can also talk about network protection for grounding, stronger technical grounding. But we have to also think about leadership, right? That's important. Risk awareness, cost alignment, and business alignment. So that's where the guts of the office is. Okay, right? Think about it that way. you know, we'll show again leadership thinking. This is just the technical accuracy, and again, I correctly explain that to you. So it's up to you to improve on. We can improve on even the security layers if you want. We could talk about the security layers, but I'm not going to. Right? We can also discuss the security layers, right? Or even the protection of the network, right? Right. So you know, use that to your advantage, right? uh, learn about learn about how that works. Understand technical understanding. Be business aware. Think strategically and communicate clearly. Right. So that's exactly what your leadership teams look for. That's exactly what um, your interviews are wanting. Again, they can assume what they want. Again, everybody has that specific um, way of doing things. But just remember, super simple, or we can go executive if you want. You can say, hey, as a cloud architect, a firewall selection is a strategic risk management decision, obviously, right? Because the firewall sits between the perimeter, right? And obviously it watches what you're doing and it keeps the bad guys out of your system to protect it, right? So at the edge of the network, it's going to protect that, right? So and then we can also and then also the IDS IPS rule is where those rules come into the plan and then works their way onto the ACL, the access control list, right? And then to the host-based firewalls, um, systems, disable any necessary ports, et cetera, et cetera, et cetera, et cetera. But you guys kind of get the point, right? Um, you know, it's the network. It's what keeps these bad guys out of the system. That we need to protect it. So represent represents the trade-off between performance, the visibility, operational cost, complexity, and cost. But from a business perspective and an architecture standpoint, security architecture might align with the organization's appetite, risk, any regulatory obligations, right? Or especially objectives for growth, right? So over engineering sometimes increases the operational burden. But so my approach is always to balance protection. It's always to balance performance and business impact. The goal isn't maximum security. It's more optimal security aligned with business needs, right? Think of it as that, and you'll understand the land, I call it, right? So, you know, if we'll get back to the fundamentals, but you know, think about the work around it and how it works, right? Because 1 second. Yeah. It's all about in the way you talk and the way you explain yourself. Makes sense a little bit of what you're saying and how you deal with things, right? So, firewall is just a network. Like I said, it's a stateful device, but it's a security device or even software based that monitors and controls incoming and outgoing traffic, network traffic, right? And that's all based off of rules that are predetermined beforehand. So firewalls establish a barrier, right? They establish that barrier between the internal networks and the untrusted external networks, right? So at the edge of the network, you want to keep the bad guys out of your system. There's different types, right? And when we talk about the types, we talk about four different types I'm going to talk about. And the first type we're going to talk about is there are four types, right? And fundamentals. And we're looking at the packet filtering firewalls, right? These are stateless, right? So one, stateless. And those are the packet filtering firewalls. In the simplest type in this we can examine individual packets without even the context, right? So you can have well, let's get a drawing board here. Let me get my drawing board here. See if I can get you a better image. Okay. All right. And I'm going to select my stamp. Right. And I'm going to bring my stamp here. But remember something, it's 2026. So I gotta change that to this year. Um, so think about, when we talk about uh packet filtering firewalls, right? We have this beautiful device. And within that, we're examining individual packets without context, right? At all, right? And these types of firewalls, the stateless firewalls are, fast. They process fast. There's not really any tracking or anything that happens that's going to um no connection tracking. There's really limited security, so you can't really stop fragmentation attacks, right? And the rules apply to each packet individually here. So if you were to talk about what a stateless is, you have your source IP, right? You have your source IP. It's a little bit bigger, right? You have your source IP, right? And then from your source IP, you're gonna evaluate yourself to the destination IP, right? And then, right? And then from here, you're going down to your destination IP, Internet Protocol. And then from that, we talk about the protocols, right? And then the protocols, you're looking at the source port, right? source port, and then from the source port, we're down to your destination port, right? Your source and destination ports and IPs. So work your way, and then from the IP, you have your rule where that uh, filter, that packet filter would either allow or deny, right? Destination port, right? And then work our way up to the top. Oh, we can to the top. We can say allow or deny, right? And this is either allow or deny. And again, very simple in its simplest type. And if we were to give you a rule logic, right, we could say if, and here's something that I've seen as a rule, right? You'll see if source IP in trusted list and destination IP equal 80, then allow. Right? Does that make sense? So if the source IP in the trusted list and destination port equal 40, that's a logic, right? Then that logic is allowed, right? So that's you're allowed. And that's sort of what the rules that we're talking about here when you're creating these specific rules. And let's see if I can get you a little bit more um in terms of stateless, because stateless, right? And look at this rule here in terms of how this is built out, in terms of how this is all formed in, right? And I'm going to this here circle, right? And pretty much, like I said, it's either allow or deny, right? And that's the crux of it. And especially when you're dealing with that, like you have to understand it's either allow or deny, right? And you know the port numbers, right? So the port could be port 80, could be port 443, right? It could be port 143, 3, right? Some ports just to kind of give you it could be 21, right? Could be whatever port that you want it to be, right? Like I said, these are just specific ports to get you going and motivated, right? And again, this all deals with in series, right? So this is all in series. And how that works is based on the individual packets. And to describe the individual packets, you have to be able to speak it confidently, right? And when you look at firewall architecture, I just don't see a security device. I see risk analysis, right? So if I were to give out more rule logics for a stateless device, firewall, and appliances, you know, we can give out different examples in common, and especially that these ones would support the stateless filtering, right? So you can have a source IP, you can have a destination IP, right? You can have a protocol like your TCP, your UDP, your ISCMP. You can have your source port. You can have the direction that it's in. You can have the TCP flags, and those are optional, right? So there's no memory of previous packets. There's no session tracking. There's no handshake validation, right? It's all about the logics, right? The rule logic, right? For example, you want to allow web traffic to a public server. All right, here's an example. All right, and I'm going to give you one more example, and then I'm going to call it a day. Right? Let's give black, black. Okay. Right. So if even if I were to give a web traffic to a public server, right, I could say if protocol TCP, if protocol TCP equals TCP and destination IP equals blah 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 blah, and destination port equals 80, then allow, else deny if it's not. Right. And these are some great rules because once we give these rules out and you know, these are some good rules to learn for the specific, you know, appliance that you're dealing with, right? So sorry guys. So, so, so look at this example here. Allow web traffic to a public server. So if protocol equals TCP. So if your protocol is a TCP and the destination IP, right, equals TCP, right? I mean, destination IP is 20.0.113.10. And then your destination port is 80, right? Because we know our destination port is 80 for HTTP. Then allow, else deny, right? TCP is 443, right? That's your HTTPS protocol. Right? You can block different telnets, right? You can block traffic from suspicious IPs. You can allow DNS queries outbound. You can block IP pings from the internet. You can allow SMTP to mail server only. There's plenty of limitations of a stateless firewall, right? Just remember that you can't really TCP handshake your SYN, your SYNAC, and your ACK. You can't track sessions, established sessions. It's vulnerable, and these are vulnerable to IP spoofing, right? And you know, we have to understand that we cannot inspect application content within our stateless firewalls, and we can't detect the fragmented packets, right? So take that to effect, and these are some limits. Here are the limitations. Limitations. Right. Oops. See if I can make this a little bit bigger. Oops. Mhm. All right. Let's go back. So think about it that way. And if we were to, again, right, we're looking at these limitations a little bit smaller in this image here. So think about it from a limitations perspective, right? So we can't verify, especially in stateless devices, we can't verify the TCP handshake here. We can't the transmission control protocol. That's TCP. And we can't um, track established version sessions, right? That are happening. These are vulnerable to IP spoofing, right? So again, just know what the limitations are. But most modern firewalls support stateful inspection, but prefer stateless filtering is common in, right? Right. So remember that, right? So when you're using stateless filtering, you're using it for a Cisco router, a Juniper router, a MikroTik router, right? You can have a Cisco extended ACL with ACL, sorry, right? These are all ACL based filtering, especially for stateless. The ACL switches they work on layer three. So you have your Aruba three layer three switch, your L3 switch, you have your Cisco switch, all used for internal network segmentation and for high-speed filtering, right? And then we can go into the IP tables for stateless mode. We can talk about the cloud network ACLs by design, right? Like your AWS network ACLs that are created stateless. Your Azure network security groups, those are stateless at a rule level. And then obviously your GCP, your Google Cloud provider, virtual private VPC firewall rules, right? Again, these evaluate packets independently, right? So I guess they stretch this, make it bigger. So where are the stateless firewalls commonly used? Again, high performance with minimal latency. That's why. Right? When we talk about a scenario with internal segmentation, all about simple control. When we talk about DDoS mitigation layers, fast packet drops. Edge routers, because they're at the edge of the network and it's protected by that, is more for lightweight reinforcement, right? The when and do not reply, the when to use and do not rely on alone for. Uh, so, you know, think about it this way, right? So we use it when performance is critical, when our traffic pattern is predictable, when you need simple access control and you're building a layered security, right? Just don't rely it alone on internet facing apps, application security, right? Stateless, right? And then you can move it to the high architecture level. Why it's why. And as an architect, we just need to know why it's fast, simple, and efficient, right? And that obviously has to be combined with the inspections and the IPS, the endpoint protection, and the zero trust policies, right? So combined with a stateful inspection for IPS. So yeah, so intrusion detection systems, um, endpoint protection, which is normally found in your, in ahead of the inside of the access control list, right? So IPS, endpoint protection, point protection, and we're lastly going to be talking about zero trust policies, right? And zero trust policies. Okay, just think of it that way. right? And we talk about our stateful firewalls, right? And then our stateful firewalls. Here, let me take this picture for you guys because I'm going to remove this and keep this for that time being. And then I'm going to, and then we'll go here. Right? Yeah, right. And then you have your stateful firewall. This tracks the state of the network connection, especially when there's you have you have either a first packet of the connection, you have a part of an existing connection, you have it related to the existing connection, or it just doesn't match any of the unknown state, right? So you have your new, established, invalid, and related. These are the types of connection states that are available in the stateful firewall. This allows TCP handshaking, right? So you can have you can allow outbound web browsing and many more examples. um, to port 80 and 443 going out, which is kind of allowing that. You can allow that. It allows the return traffic automatically. So establishing the packets returning, so you can allow that automatically. It's more secure than packet filtering, and it's higher resource usage, right? So it uses a lot of resources. So no explicit rule needed for the return traffic, right? Number three is your application layer firewalls, proxy firewalls. Oops. Application layer firewalls, right? Or proxy firewalls, right? And this inspects the traffic at the application layer. So you'll have the client, and that client is a two-way connection to the proxy firewall, and that firewall is connected to the server, right? So to the up, right, and this is all done through the the proxy examines the HTTP headers and content, any SQL commands that are created, email content, application specific protocols, et cetera, right? So again, it's all meant for deep packet inspection. These application layer firewalls, they hides the internal network, which is great. Can filter based on content, gives a lot of overhead performance, and can break some applications, believe it or not. Right. So just be careful of that. How you guys do that, especially with the application, it might break it. And then the last one, most important one, is the NFGW. Oh, sorry, NGFW. I call this the next generation firewall, right? And the features are stateful packet, DPIs, IPS, intrusion prevention systems. Sorry, IPS is intrusion prevention systems. I spoke about that before. And then the intrusion detection systems is IDS. There's it's basically self-aware for these applications, user identity integration. It shows decryption of TLS and SSL, secure socket layers, transcription layers, sockets, threat intelligent feeds, uniform resource locator filtering URL, and anti-malware, right? So it identifies application identification is regardless of the port that you're using, right? So the next generation firewall that's integrated, you can integrate this with AD, believe it or not. And we can use user-based policies in ADUC as security groups for users, and we can integrate IPS. like I said, prevention systems, cloud integration, and encrypted traffic inspection, right? So think of it that way. Think of it how that works in the fundamentals aspect of it. So let's go down to the architecture, and this in this scenario, I'm going to draw the four ways of the different architectures, and I'm going to quickly explain how a firewall deployment architecture, these four different types of deployment firewall deployment architectures work. Excuse me. And I'm going to kind of give you the cloud and security architecture perspective with networking involved too, right? And then the business, right? Acumen, right? Risk management, et cetera, et cetera. So let's see what we can do here. In my first, let me grab my drawing here. And the first one we're going to talk about, and I want to get my stamp here. Just want to get my stamp. Let's get my stamp here. Okay. So, so we're gonna break this step by step from perspective of a cloud and security architect with some business stuff and networking rationales, some give you some security trade-offs and some business applications for each firewall. But I also want to provide the fundamentals, and as we did provide the fundamentals, we now move on to the architecture, right? The small architecture. Now, when we talk about perimeter firewalls, we talk about anywhere at that edge of that network. So, we can have the internet, right? And then within the internet, we can have a building, right? And then within that building, the edge, right, is where the firewall would be, and you would have your internal network. So you can divide this into two sections here, right? Where you have your firewall, your perimeter, along the perimeter, right? So along the perimeter of the internal network. So think of it that way. Um, your internal network, your ISP network is surrounded by obviously routers, right? And firewalls too. And these internet routers are running, IBGP across their networks to carry routes, right? And then you're left, say, for example, you had two routers here. Let's say you had a router here, right? A router here, right? So, and then you had your network inside. So these two routers, right, would run IGP between each other, right? And then this would run, oh, and then this would run IGB, and we're talking about multiple lines here, right? This is more of the advanced side, right? But like if you're looking at it from a network perspective, a single firewall sits between the internet and your internal router, right? So, the single firewall itself, the firewall, right? So if this was the firewall, right? This firewall is sitting somewhere, right? It's got to sit somewhere. And as it sits somewhere, it's going to sit in between your internal network, right? So your internal network, which is your ISP, right? So this is going to be your internal network, right? And then this will be a router. This could be your left router or R1, and this could be R2, right? Again, all between that is where that single router is going to sit, right? And that's going to control any inbound or outgoing connections that are coming. So anything that's coming from the internet, anything's going to the internet, right? And that's based on IP ports and protocols, right? So this is where the IPs come in. This is where the ports come in, right? I don't have my pen here, guys. My apologies, but you guys kind of get the gist of things, right? Oh, right. IPs, ports. You also have protocols, right? Protocols as well too. Right. I'm using a mouse here. I'm not using a pen. Right. And again, this is live, raw, and in demand. So, from a security perspective, the perimeter firewall, which is um, one of the architectures, right? Right. Our first architectures are perimeter firewall. We're looking at and this right here is a traditional boundary protection, right? So this is all boundary protection. So this is traditional boundary protection, right? Remember that. So remember that. And as we move along, right, we start talking about the traditional castle and moat model, like call it. There's basic protection against external threats, right? So it's sort of like the castle and the moat. Um, Cat segment internal apps or applications, or protect against any lateral movement whatsoever, right? So you have to understand that there's basic protection against the external threats, right? The external threats that are coming in, and the external threats that are coming in are very important, right? Right? Yeah. And then protocols. So, you got your two routers. They both run IBGP across their networks to carry routes, and they run IBGP from the routers to the in a pattern here, right? So it runs in the pattern to the internal network. So the whole box is the internal network, but you guys kind of get the gist of it, all right? It would obviously be at the edge of that, or is somewhere inside the internal network itself. But think of it that way, right? And they're going in and they're coming out from the router, right? Or from the firewall, right? And that uses IP ports and protocols for that part, for controlling of inbound and outbound traffic, right? So security perspective, we talked about the network perspective. Now let's talk about a strategic business perspective, right? There's pros of it. The pros for this one is low cost, easy to manage, very simple when we're deploying it, right? The only cons I see of it in this perimeter firewall, from my experience, is the internal segmentation. It's minimal and the higher risk if the firewall is breached, right? So have that in the back of your mind. These are suitable for small businesses or lower regulation environments, and that's where the cost efficiency is key, especially when you're designing um, a system in place for the business, right? And when we look at the trade-off values, we're looking at security versus the cost, right? Cost, right? And these are good for simple networks, right? They're not really recommended for any high risk or just a regular environment. So think of it as that way. And I'm going to take a snapshot of my first one, perimeter firewall. Actually, let me write this down. This is perimeter firewall. Perimeter firewall, right? And this is what a perimeter firewall architecture, right? Okay. I'm gonna take this. I'm gonna take this whole thing and I'm gonna bring it here. And I'm gonna put it into my notes for architectures. Right. So remember what we talked about here. And then we can remove all this. We don't need all this. Delete, and we can start from scratch. So second one is going to be our DMZ architecture. Right. Think of it as, again, the same concept, right? And as we were designing here before, so you have a internal internal system in place, and that's private, or an internal network that's private. And this was going to be our DMZ, which is our public, and then this is going to be our internal network. And if we're looking at, and this is going to be public and private, right? Right, and then we'll have our internet here, for example, right? And then we'll have our firewalls here, right? And our routers. We can also have our routers if we want, just so that we need routers, because our routers will need our routers for internet, right? So you'll need routers for internet. Right? We know what that is, right? And we know what our firewalls are. We know that our firewall is can be anything, right? Based on the four that we talked about. And we'll also have our DMZ, right? So this could be our DMZ. And we know that our DMZs are public, right? And then we'll also have our internal private, right? Our internal network, which is private, internal network, right? And we know that that's private. And then this is our internet, right? So if we were to start drawing upon the designing our network perspective, our demilitarized zone, or DMZ, our demilitarized zone is a separate network segment, right? So this is all segmented, right? Border, right? For public facing services like web servers, right? So anything that's public facing. So whatever is public facing, we can have like our web servers, our mail servers, any APIs, right? APIs, right? We'll have our web server, our MX server, mail server, right? And our APIs. Now, the firewall routes traffic. So the firewall routes, so whatever the routes are, traffic from to either the DMZ, so the firewall route, so whatever the firewall route, either call through the router, the firewall to the DMZ, right? In turn, or the internal network. So you got web server traffic going through the firewall into our internal network, right? And that's private. Now, that's just from a network perspective. Now we talk about a security perspective, and this is where we're adding a layer of isolation between the services, the public services, right? So we're adding a layer of isolation. We're isolating this somewhere, so it's separated from each other, right? Between the services and the sensitive information of these internal systems, right? So limits exposure, even if the DMZ is compromised, attackers cannot directly access the internal systems, right? So there's a block in between here, right? And they can't go through this, right? Through here into there. And, you know, that limits exposure. Even if the DMZ is compromised, for example, you've got it attacked. Attackers can't directly come through here. So any of these attackers that are coming through inside our machines, right, and then attacking us into there, they won't be able to do that, right? So they're limited to that, and they can't really expect there's that perspective when it comes to the DMZ architecture, right? So, um, you know, it limits the exposure of having to do that, even if it's compromised, right? So even if it's compromised, that DMZ is not being touched. The that internal network is not being touched. Um, Business strategic perspective, again, a big pro for us would be, providing a strong security boundary for any services that the customers are facing. You know, cons, towards the business side, yeah, it's slightly higher in cost and management overhead than a perimeter firewall, right? Right. So think about it that way. And, it balances the security with, um, we're balancing the security, right, with operational efficiency. So anything that's common in a mid-sized organization, just a regulated business, right? Trade-offs for adding protection. We're not really doubling down on the infrastructure. And this is best for like publicly accessible apps, right? So any public applications. So any applications in the DMZ or any applications in the internet accessible by the users, right? Accessing these applications. Access these applications. Okay. Yeah, that's that, right? And this is where the third option here is the three-legged firewall, right? So we'll talk about the three-legged firewall. And that's another type of architecture I've seen. You take a snapshot. Oops. So I'm gonna take this picture, copy it into my notes, right? And I hope you guys are doing the same thing too. And taking notes for this as we talk, right? Remember, watch this twice, not once. And we're talking about a three-legged firewall next, and this will be a third out of the one last one. Um, I can give you guys a summary table on the architectural and business lens and how it fits in terms of a basic high and low, medium high size, right? Give you some takeaways on that. And overall grade the explanation to this would be a nine out of a 10, right? And in leadership and technical clarity, and even just in understanding security and the business acumen, the 10 out of 10. We're here to clearly link architecture to costs, clearly link this to compliance or any operational impact that we have, right? So if you want, I can also, do that. If you want, just message me the word um, firewall in the bottom comments, and I'll send you over that table. I'll send you over that table. We'll talk about the three-legged firewall. And a three-legged firewall, this is going to be the third of the four designed for this lecture. And, we're looking at the three-leggeds, right? So we have our internet connection, right? We have our firewall. Oops. We have our firewall, right? Then we have our DMZs. We have our internal network, right? And we have our management network, right? So DMZ, internal network, and management network, right? These are the three. Internal DMZ, internal network, DMZ, internal, and management network. Right? We have our firewall. We have our internet. Call this the three-legged firewall. All right. Three. So think of it this way from a network perspective, from a security perspective, and from a strategic or business perspective, and the trade-off involved in this three-legged firewall. As we're looking at this, right, we have our connection that goes through the firewall to the DMZ. We have a connection that goes from the firewall to the internal network, and then the firewall to the management network, right? And with single firewall, with three legs connecting to the DMZ. And that's where our three-legged firewall comes from. This supports multiple zones just with one firewall device, right? So I'm supporting a zone here, right? This is a zone one. This is a zone two. This is a zone three, Z3, right? Oops. This is zone one, Z1, right? This is Z2, right? Z2, and this is Z3, right? You have to understand that, you know, we're supporting multiple zones here, and this one device firewall, right, is supporting that with the help of internet, right? And that's important. That's important. That's actually really, really important, right? And I'm going to erase this, sorry guys. See if I can draw this here. Okay. Yeah, you guys see that, right? You guys see that, right? Okay. Right. Doesn't matter what zone numbers there are. They could be in any order. Again, south to north, east to west, left and right. Just remember that that's where the network comes in, right? So it's one firewall, right? F1, right? With three interfaces, right? Interfaces. And we're looking at the DMZ or zones, interfaces like your DMZ, your internal network, and your management network, right? And it also supports multiple zones within that one device. right? So from here, you support a zone, zone 2, zone 3, right? Is providing segmentation. So I can provide segmentation to zone 1 and 2. I'm segmenting these two, internal network and DMZ. And that's just for internal, external, and DMZ traffic, right? So I can do that. But with I can allow one traffic to go through here and here, and not here, and then create another rule here just for this, right? So I can have centralized control for monitoring and enforcing policies across all zones, right? So I can control and puppet the monitoring and the enforcing of the policies, right? So the policies that come down to these policies, right? The policies that you're creating for these zones or for these segments, right? And this is suitable for mid to large enterprise environments. I've seen this a lot of places, right? Um, Business strategic, again, pro here is, hardware simplifies their monitoring, enforces separation of critical systems, right? So wherever your critical systems are in your network versus your non-critical machines, right? Um, Single point of failure, SPOF. If the firewall is compromised, all zones are risk. So if this is assumed SPOF, right? Your single point of failure, right? Then these machines are down, down, down. They're all down. They're all at risk, right? So if the firewall is compromised, they're all at risk. There's a single point of failure here, right? So there's no really redundancy here. Um, and this picture that I wrote, right, with one device. So it's always good to have two. So offer a cost-effective solution for multiple security zones, balancing operational overhead and security coverage, right? So offer those cost-effective solutions like the pricing, the packages that are involved, the types, the brand of the machines that you're doing, right? Uh, the pay-as-you-go services that you have, um, day-to-day services, turning them off when you're not using them, stuff like that, like just overhead and security coverage, right? So trade off your economical multi-zone design versus a risk of right. And thinking about that, you're looking at the risk of single point of failure, which requires redundancy planning. And I talked about the redundancy. If I were to break this down, you know, a three-legged firewall is a single device, right? So this is F1 is a single device, and it protects three areas of your network. And these three areas are your DMZ, your internal network, your management network. This design is cheaper because you only need one firewall instead of many. It's cheaper, right? But the problem is if the firewall stops working, you're done, right? You're done, right? So you need a secondary solution. You need an F2, right? For high availability. So you need that F2 to route traffic through to it, right? Within your and take the internet and route and redistribute the routes, millions of routes that have to go through here, right? From that explanation. And again, cheaper because you only need one instead of many. But the problem is again, if it stops working, all three areas are risk. So big companies will usually plan extra backup firewalls for redundancy so that if this one fails, right, the network stays safe. Right? You're now safe, right? You're now safe. Okay. Um, and that's your three-legged firewall. And I'm going to take this picture and put it in my notes, right? And again, our fourth and last one we're going to be talking about is our dual firewalls, DMZ. So we have an external firewall and an internal firewall, which is kind of cool. You have your external firewall that's connected through the internet into the DMZ, um, to the DMZ, external internet to DMZ, internal DMZ to internal, right? Firewall. And that's our internal network through the internal network to the internal, sorry, through the internal firewall to the internal network. So that'll provide two firewalls. In this instance of that design and why it's used, and you got to look at the pros and the cons and how these firewalls work, and the network perspective versus excuse me, and how that works, and the security perspective versus the strategic business perspective, and any trade-offs, right? So we're looking at that layered defense in architecture, right? And fundamentals, you just need to know what they are. That's it, right? You don't really need to, you know the different types of the like the stateful firewalls, the application firewalls, know about the NGAWs, the next generation firewalls. You don't really need to know how it's designed, but you need to know how it works in tandem, right? So takeaway, architects only, not analysts, not engineers, takeaways for architects like myself and engineers who want to learn architecture. Always combine, get your layered defense, always combine the firewall with segmentations like or IDS, IPS, intrusion detection, protection systems, any endpoint protection systems, any trade-offs matter, like, security depth, of that cost and complexity. Balance it with any objectives that you're looking at regarding plan, right? Zero trust readiness. Again, firewalls aren't enough, even if you had to assume breaches and enforce at least privilege and segmentation internally, right? So choose the right architecture, demonstrate the right architecture, show demonstration awareness of risk, show what the operational impact is in the regulatory compliance, right? So last one, I'm going to bring out this picture and I'm going to highlight the mess here, the debauchery. And again, this is dual firewall DMZ. Okay, what does that mean? Um, so what does that mean? What kind of firewalls are these, right? And again, we're gonna draw it. We're gonna draw it where you're coming from the internet, right? And you've got your external firewall, right, outside, right? So you have your divisions, right, of outside to ins. Oops. Understand there's an external and an internal. I'm gonna make this a big gray line, right? And again, remember the external part of it, external, right? All right, and then internal, inside, right? Then we have our internet, right? Public internet, right? Connections, and you can have multiple internet connections. You can have multiple ISPs connected to the routers, and then external ISPs, right? And then you would have your internal network, your ISP network. Um, you know, and then you'll have your BGP and IBGP running between those routers, right? If you need it. So you'll have your external firewall as well too. You just won't have internet, but you also have a firewall, and that could be software based as well too, right? And in the cloud, and that's normal. Like that right there is normal. right? So you have your firewall, and then you also have your DMZ, right? And then you have your DMZ, right? And that again, that could be anything, right? And we're still at the layer of um of the internet, right? And you'll have your DMZ network. And you can have an external firewall, right? Where you have your internet and DMZ, and then you can have your internal, which is your DMZ and your internal network within those other two examples that I showed you, right? From that external DMZ, right? You have your internal DMZ and your internal networks, firewall, and then your internal network, right? So from the DMZ, you'll have that'll be connected to your internal firewalls, right? Right. So you have your external internal firewall, right? And then you have your internal network. Does that make sense so far? It's really straightforward, right? It's all design. It's all by design, right? So this is your internal. Remember, we're internal now, right? Remember that. And then we'll have our internal network, right? You have your two firewalls, right? Your internal, external firewall. So we'll call this an external firewall. This is external firewall, sorry, right? Because it's external. And the firewall usually sits at the edge of the networks, right? So at the edge of whatever the network is. And we look at when we look at the edge of the network, we're looking at it as either a stateful device, we're watching what it does and what we're doing, and that keeps the bad guys out, right? So think of it as that. And this is internet, right? Or an internet connection, right? Erase this, right? So remember, DMZ, firewall, external, internal, you're providing assurance and as high assurance segmentation between the public and the internal services, right? So you have your public services and you have your internal systems. So whatever your internal systems are, and then your services that are publicly um, segmented inside the network, right? If I were to break this down, so if I were to expand that, what I just said, so imagine your company network is like a castle. You don't want your company network isn't again, your company network is just it's like a big castle, right? So that castle there, you don't want strangers. You really don't want strangers. Um, you don't want strangers, right? From the internet, from your internet connections. You don't want strangers from the internet to get to the treasure inside. So it's gonna stay here and it's gonna redirect back up, right? It's just going to go back. It's going to stop. It won't allow you to do that, right? So to get to the treasure inside. Now, say that treasure is inside the castle. So with a dual firewall setup, you have two gates. So you'll have two entrances, right? Two entrance doors, right? And then you have this one here, right? You have the door opening this way, and then you'll have the angle, right, of the door. So you'll have one and you'll have two, right? The first gate is the external firewall. The first gate is the external firewall, right? And that sits between the internet, the first gate, is the external firewall. And that sits between the internet and a public area called the ZMZ, right? So sits between the gate will sit between the DMZ and the internet connection. You understand? That's called the DMZ, the public area. So the DMZ is like a visitor area where services lay in. So the DMZ is where the services are. So that's where our services are. Right? We'll have our services there, right? And like our websites, right? So we'll put our websites in here. We'll put websites, right? Our websites will go in there. And the firewall stops the bad traffic from the internet getting to the DMZ. So this will stop it from getting to the DMZ for a web server. Our second gate, right? Our second gate, and this is our first gate. Our second gate is our internal firewall. That sits between the DMZ and the internal network. Right? So it would sit between the DMZ and the internal network. The DMZ and the internal network. So it would go from here through the firewall to the DMZ to the internal network. Okay? Right through that gate. The internal network is where the private data stays. So this is where our private data is going to stay. We'll have private data here. Okay. So we'll have our services like our web servers inside our DMZ. And then we'll have our internal network, which will have our private data, right? So we'll have private data in here. Right? We'll have employees' computers. Does this make sense so far? We'll have sensitive servers. And this is where that is. Even if someone gets past the first gate, the second gate protects you for the most important services, right? So think about that way. Your internal data, you have your first date, you have your first gate, then you have your second gate. Again, this setup gives you high assured segmentation, right? So, you're segmenting the two areas, your internal and external gates, right? And even if someone gets past that gate, the second gate's gonna protect us, especially for our sensitive computers, or right. So employees, private data, sensitive servers, computer sensitive servers. Okay, straightforward, and that's within it now, which means each area separated, each area that we talk about, segmented, means that each area is separated and protected, making it much harder for attackers to move around if one part is compromised. So if your internal, well, if your external is compromised, you can have it won't move it because of the two separate gates that are created within this dual firewall DMZ, right? And from a network perspective, the company keeps its sensitive data safer that way, like, and then the trade-off here is, hey, it might cost more because you need two firewalls and someone to manage them, right? You can talk about AI here if you want, um, solutions on that, and have one person manage that instead. Your benefit, extra safety for your most important systems, which is worth it for big companies or banks, right? This is more for big companies or banks, especially if you want more safety in those systems that are important, like the private data, the employees, the computer sensitive servers, right? Um, you know, we're looking to not only clarify technical the criteria of technical accuracy, its overall understanding of the security network, but also to explain the cost versus the protection in simplest terms, right? So think of that dual fire DMZ as that as what I said, right? We when we look at firewall architecture, I don't see a security device. Again, I see risk control decisions, right? So those stateless firewalls are fast. Stateful devices or stateless devices are fast. But the stateless firewalls are fast but limited, but the stateful add context and better protection. So you'll be going with a stateful firewall in certain thing. Then you have your next generation firewalls, and again, those provide the deep inspection and user awareness, but increase costs and operational, right? So think about that. If you found this breakdown helpful, especially the leadership and especially the architectural perspective, and making sure to like the video and subscribe for more discussions deep on cloud, on security, and enterprise architecture. Remember, security is not buying about more. It's not about buying more tools. It's about making smarter trade-offs, right? And the fundamentals are just as important as the architectural. Just remember that the positions are different. The best architects don't just design secure systems; they design them scalable. They design them for business. They design these systems that are business aligned, and they design for resiliency. Thanks for watching. I'll see you in the next one.